I guess what I'm trying to say is, I guess I had a project and we had an idea, but first we had to see if Patrick could do it because we've never done this before. It's Acme thread, huh?
Yeah, you asked me how I felt about turning an Acme thread.
Yeah, just a normal question I ask every day.
Okay, this is actually my first attempt, and I have to say it came out pretty good.
Oh, that's really good. I think that looks great.
Yeah, isn't that? And it's actually, let me show you, it's actually functional. I should probably show that, huh?
Yeah, I'm getting excited.
Yeah. See, this kind of gives you an idea how our wall thickness is going to look like after we bore out the threads. So that's the front. And the rear, see the rear, we have a little bit more
there's a bigger
material.
Yeah, there's a bigger step back there.
Yeah. I want to be sure I get it on this part very well. And then when I insert the part, you're going to see that you want to insert these in a twist turning motion. So as you're pushing it
almost like you're threading it in a way.
Exactly.
Dobru Pozholovitz.
What the heck was that?
Well, that's... well, you didn't know that? That's just welcome in Russian.
Wow.
This is Shop Adventures 42. I'm Lance.
And I'm Patrick.
Well, now, why am I talking about the Russians?
Yeah, why are you talking about the Russians?
What's wrong with that guy?
Okay, yeah, well, let me go back. Okay, we know a Russian YouTube creator.
We do.
His name's Sid.
Cool.
His YouTube channel name is Special Instrument Designs, and we'll include a link in our description.
Yeah.
So, and the reason why we bring him up is because about, a few weeks ago, we sent a package to him.
We gathered up a whole bunch of American-made products and things and shipped them over to him, all machine related.
Yeah, we had fun with it.
Oh, yeah.
Yeah, if you want to check it out, I think it's not his latest video, but a video
prior.
Yeah, prior. But you'll see it. It says Active Atom in the description.
It does.
Yeah. Yeah, he's a really nice guy, and we've been watching
him and a friend, isn't it? It's like him and a couple of guys. A couple of guys come in. They got a sense of humor. They think they're comedians like me over here.
Yeah. But the reason why we started watching him a few months ago is, no, actually, we've been watching him for about a year, maybe.
Yeah.
Yeah, and the reason why we like him is because, you know, all his topics are machine related, obviously.
Yes.
But what he does is does a lot of research and shares, you know, that research and everything.
I'd say, like us, most of his videos is research.
Yeah.
And then he conveys it really well, showing you what happens.
That's right.
And it's real diverse. It could be a surface grinder one day, and it's a little tool grinder another day, and it's a meal one day.
That's right, the variety is really nice.
Scotland, I believe it is. Scotland?
That's right, a Scotland mill.
Which I like, yeah.
Yeah. So yeah, it's a really interesting channel.
Yeah.
So yeah, we just started watching him and we started communicating with each other because, you know, we're all creators.
Yeah.
And we sent him a care package. And he was really nice. He did a really, like a little parody bit.
Yeah,
you know,
he did.
With our company.
And remember, in our minds, and we do this globally, machining is an international language.
Right.
It's irrelevant whether you can speak Chinese or Japanese or Russian or...
Oh, good point. You know, his video, let me warn you, his videos are in Russian, but for most of his videos, he does translate them to English.
And you're now aware I don't speak Russian, is that clear?
Yeah, we don't speak Russian.
You can figure out how I probably slaughtered that poor word welcome.
Yeah.
Okay, that's nice.
Yeah, so really nice guy. Check him out.
What did we do this week? Oh boy. We did it, didn't we?
Oh yeah, with Acme threads.
Yep.
That was really interesting.
We've never done that before.
I mean, we've done threads. We've done
not Acme threads,
your
though.
Common V threads, but we've never done an Acme thread.
No, they're not that big.
Yeah, and those are deep threads. Boy, are they aggressive.
Yeah. You're gonna like this, though. We had a good time doing it.
Yeah, but we were going to share if we were successful or not.
No.
We did a test part. The test part was successful. So then we said, okay, gave us the confidence to start this project, and you have to check it out, see if you're successful with it or not.
That's the way it works.
Yeah.
Our website has been a busy place, hasn't it?
All right.
We've got downloadable MP3 files.
Right.
Very exciting conversation shared by my vocal voice, isn't it? On doing, well, we did the one, this is our second one now we've done is the Woolite.
Yeah, well, if you want to check it out, it's on our website, activeatom.com. You go in the menu, go to resources, and it's under Active Atom articles.
And it's pretty good. There's a couple of them there to share. You can just, they're audio files, you can listen to them, follow along with the document there. But most importantly, honestly, what's really up there that we've put is some very hard work.
Oh, finally. This is long overdue. People have been asking and asking, and which we promised, so I don't blame everybody. But we finally have all the documentation and forms in regards to our spindle rebuilding educational videos. And if you go to our Active Atom website again, it's under resources, and then you go to Active Atom Education. And then on the left side, there'll be a little menu, and you want to go to Precision Spindle Rebuilding. And we have all the documentations related to all the videos
that have been released.
Yeah, that we've released to date.
Right.
Okay. We've also have 2 forms. You know, there's like a parts and supplies checklist form.
That one's good.
Yeah, that one's good. And there's also a break-in procedure form, and that's really nice.
Yeah, I wish I had that when I did the actual break-in.
Oh, yeah, that really
I do mine the old way we usually do it.
Just on notebook paper.
Yeah,
right?
it worked.
So we did, and please check back, every once in a while. Because,
that's a live document.
Yeah, we're constantly updating it.
Yeah, it will be until the series is done, and we've gone down the road a ways, and then we'll wrap that document up and stay in a PDF locked up file, and that's the way it'll be, and
that's
no more upgrades, but we value input.
Yeah, definitely.
So, criticize away, we love it. Yep. Right? Help us. Okay, we have a big, giant shout-out thank you. It's to 2 Keiths and a guy named Jeff.
Oh.
So yeah, it's really a kind, the man works very, very feverishly to build one of those beautiful websites of great documents and data, beautiful information, great blueprints, nice photographs.
Yeah.
Great documentation, serialization numbers from steam engines to powered engines to woodworking to metalworking. And they've included our Levin lathe and Barker milling spindle rebuilding series as a playlist.
Yeah.
Inside of the vintagemachinery.org.
Yeah,
website.
And again, of course, we'll put a link under the description.
We're real proud and honored to be included there. Means a lot to us, doesn't it?
Yeah, it really does mean a lot to us. So we really appreciate it.
And then a viewer had asked us, a fellow creator actually had asked us, do you actually use steady rest? And I said, that steady rest is the most unappreciated, most unutilized tool I think a lathe has. I don't know of another attachment.
That's true, because most people, they just put them in a drawer and never sing for, until once in a very long while, if at all.
So, so we've paid homage to it, and a fellow YouTube creator, who everyone likely knows already, that has a little steady moment.
True.
And I think that's everything we have this week.
Yeah.
Right? So I just think we ought to get out there and let's get out and see just exactly how we did on the Acme threads.
Great. Let's get started.
All right. Thank you very much.
Great. Bye.
Bye. Well, we're both wearing blue coats. This is an exciting moment for me because that means we're in
the machine shop.
That's right. Summer's come to an end just in the last few days, and we've head off into fall. We're not into winter yet. That's when we get to play outside.
Yeah.
But for now, we're able to make our way a little bit into the machine shop, which has been neglected and missing us as we've only been out here just a little bit.
Yeah, because we can't really be out here in the summertime.
No.
It gets pretty warm.
Even today, it's 85, 90, but we've had, in the summertime here, it's 115 to 120 degrees in the machine shop with the doors open.
Yeah.
And the fans running because we don't have air conditioning here.
No.
So, okay, so now we're out here. I guess what I'm trying to say is, I guess I had a project and we had an idea, but first we had to see if Patrick could do it because we've never done this before. It's Acme thread, huh?
Yeah, you asked me how I felt about turning an Acme thread.
Yeah, just a normal question I ask every day.
Because for those that don't know, I'll get a better close-up picture for you guys. But an Acme thread is a square profile thread, and this is used a lot on lead screws for machines.
That is a Y-axis lead screw for the Barker mill.
Okay. And then this one must be for the X-axis.
Yeah, that's it.
Okay, great.
Yeah, they're just giant, you know. It's a whole 10 inches by 4 inches of travel there with the nuts and stuff. And this is bronze, by the way.
Okay.
I don't know. So that's kind of hinting to where I'm going. But first, I don't want to talk about any of that. I want to come to Patrick and see how we can do this Acme situation here.
Okay, I've always been intrigued because, you know, as you know, I use a certain, only on this larger lathe out here, I use these little threading inserts. And let me get a better close-up view.
Perfect.
Okay, let me first show you the threading insert type we use on our larger lathe here. Okay, let me see if I can get a better view for you. Okay, can you notice the V profile? Okay, these inserts are for your common V threads, which have a 60-degree angle. Okay, and so, you know, every time I've gone through the catalogs for these thread inserts, you know, they show you the different threading profiles or thread types that you can purchase. And I've always looked at the Acme thread options, and I was always intrigued. I always thought, wow, it'd be really fun to have a project that entailed, you know, turning these threads. So when Lance approached me saying, hey, you know, what do you think about turning some Acme threads? I go, wow, that's great, sure.
I've never done that.
Yeah, why not? So first thing I did was I, you know, placed my order. Purchased 2 types of Acme threads.
Oh, he loves to purchase tools.
I do. Okay, and as you see here, a much different profile, as you can tell. So make sure you get a good...
Well, that looks like it's almost square.
Yeah, doesn't it? You almost think, you look at the thread, and you actually think it's a straight...
It's straight with flat tops. That's just how it looks, you know, as you just glance.
It really does. But it actually has a 29-degree combined angle.
Oh, okay.
So, oh, and the 2 types I purchased was, you know, I wanted to purchase a version to do outside or external threads, and then I also bought a version to do internal threads. And you can see they're exactly the same. It's just that the cutters are on opposing sides from each other.
Well, that's a big boring bar for us.
Yeah, look at that. And so we can actually... we're going to have the ability to do internal and external threads, which is really good because you never know. You know, I think Lance was telling me this project's going to entail internal threading, but I always wanted, when I purchase threading inserts, I always want to purchase both because you never know. You know, it's always nice to have both. Sure. And especially for, you know, I've never turned Acme threads before. Okay, this is actually my first attempt. And I have to say it came out pretty good.
Oh, that's really good. I think that looks great.
Yeah, isn't that? And it's actually, let me show you, it's actually functional. I should probably show that, huh?
Yeah, I'm getting excited.
Yeah, see? See, it's nice and tight, much tighter than, oh yeah, really good.
Oh, so really good.
Really nice and smooth. So for my first attempt, even I was a little surprised. So if you've never turned Acme threads before, I highly recommend these thread inserts. Really made the job easy.
And I see that threading work came out pretty good there, so am I supposed to get a little bit higher vote of confidence here, and maybe I'm going to get a little excited about my project we're about to share?
Exactly. So isn't that beautiful? I mean,
because at first we were like, let's buy these tools, give it a shot. There might be something complex about these Acme threads. We've never done them, and they're kind of square, and I don't know how well they got to last and how long they fit, and we don't know much.
Exactly. You know, anytime you do anything for the first time, you don't know what to expect. You know, you don't know if it's going to be really difficult. So I was really impressed. You know, it even surprised me how well it went.
Oh, good. Maybe we can save a little money, make some parts better, make the tolerances even tighter. Oh boy, am I excited to share this project. Wasn't sure if I was going to get anything here other than some new tools. Wow, now that we're all done confirming that the Acme thread can in fact be done with great precision here.
Well, I'm not sure about precision, but it looks good.
Well, don't look at the deer that's about ready to look in the headlights because he has no idea what I'm about to say. He knows he's going to be making a nut insert for this.
Yeah, I can kind of see.
Okay, we're going to reinsert these because they've gotten old and sloppy.
Well, I knew once you told me about this project, I kind of knew I had to do something with the lead screw.
Yeah.
Yeah.
And they're washed out a little bit. Not really, though. I thought they were. But until we ordered this brand new Z-axis left-hand screw.
Yeah, because...
There's a left-hand thread.
Yeah, because when we purchased the Barker mill, it never had the lead screw.
It's an option.
Assembly. Yeah, it was an option. It just had the lever.
Yeah.
And but you know, in our case, see, our Barker mill is really unique. For those that don't know about it or just joined us.
Oh yeah, let's take a picture. You want to share a picture of the machine?
Yeah, that's true. Let me show you a picture of it. Okay, yeah, what makes our Barker mill really special, it has a vertical milling attachment.
It does. And these are second operation machines. They're not production machines. Well, they're production machines for second ops. They do single function all day real well with high-speed levers.
That's right.
Locks and table locks and high-speed levers, and it's really something. They got big funny handles on it, big knobs and big funny handles. I cannot wait to show you as we assemble it.
Oh, yeah.
You're going to love it. Okay. But that being said, this is from the factory, and you can still buy these nuts. It was either, okay, buy 2 nuts, it's $500 for the pair, and they're good in stock, just so you know. I mean, factories still exist, right?
Yeah.
But, after seeing this left-hand one...
Yeah, there was a lot of play, more than we thought.
And I can live with that in the Z-axis. We lock that down on what we're doing anyway, and we use the coil on the mill. That's
Absolutely,
where we're at.
On the vertical head, right.
Yeah, so we have that luxury. We have that rare option.
Yeah.
But on the X and the Y, the backlash was going to be too horrendous already. And we didn't think spending $500 was going to make it better.
Yeah, that's
a lot better.
Yeah, exactly. No, you're right. I agree with you.
So I'm going to get caught with the deer in the headlights syndrome here, but I'm going to try to tighten the tolerances with Patrick here. So we're going to machine these inserts and put them in here in these existing nuts and save money because we need that for the product we're going to build here. We need every penny. That's how it is. But we can't buy it. We actually really wanted a higher tolerance. Our goal is to get a higher tolerance without making the bronze wear, because the lead screw is one thing we don't want to wear.
Sure.
So the nut at any price is well worth it, so long as we don't ruin the Acme threaded lead screws, because they're that's a lot harder to make.
Sure.
So that's what these are designed to wear, and they have worn. And then we're going to build it and try to get the tolerance tighter, but make it so not that it's not just good for one day, but it's good for like a year from now, still just as good with a limited amount of backlash, a lot more tighter tolerances for the kind of work we do. We kind of need to want to try to shoot. That's why he's going to look funny at me, because I just, good is never good enough, and we want to go a little bit better, and we know we can. Huh?
Yeah, because I knew we had this issue.
Yeah.
But what you didn't tell me is I originally thought you were still planning on purchasing these from the factory. So I'm actually...
Do you think you can do something then?
Yeah, I mean, I think... because I think what we could do is maybe make like a thread insert.
Okay.
And then what we could do is just bore these threads out. So basically, we would just clean this up. So we just bore this out to remove all the threads. And then we make a separate thread insert.
Oh, a fresh new thread.
Yeah.
Oh, okay.
And
press it in or something, whatever.
Yeah, I'm just trying to think. I'm not sure how much room we have, because if you see, it's already pretty thin wall right here.
Yeah.
So because preferably, it'd be nice if we could put a set screw, but I just don't think we have the room for a set screw.
No.
But let me do this. You know what? Let me play with this now that I know what you want to accomplish. Let me play with this on SolidWorks and give me about an hour or so. And we'll be back, and let's see what I can come up with.
Oh, I'd like that. Yeah. I hope we can do this. I hope it'll be really great for us.
Yeah, because see, in SolidWorks, I can go ahead and model this and play around with it and visually see, how it will look once I bore this and see what kind of wall thickness we have.
Yeah, that's an incredible software. It's pretty powerful.
Oh yeah, we love it. So
right on. Thank you.
We'll be right back.
Okay.
Okay, I'm back.
Jeez, what took you so long? I've been waiting out here all afternoon.
It hasn't been that long.
Nah.
Okay, I think this is gonna work out. I'm really anxious to show it to you.
Well, I like what I'm seeing. We're gonna share this?
Yeah. Okay, let me show you this first. Okay, this is just to give you a visual of how it's going to look after we do the initial machining. Okay, two things. Okay, as you can see here, I've modeled the bracket that we showed you earlier.
Oh, look, it looks just like that bracket.
Yeah, doesn't it? Okay, one thing you can notice is you can see this is how it's going to look after I bored the threads out. Okay, so that kind of this is actually good. See, this kind of gives you an idea how our wall thickness is going to look like after we bore out the threads. So that's the front. And the rear, see the rear, we have a little bit more
there's a bigger
material.
Yeah, there's a bigger step back there.
Yeah, and that's really helpful for us because see, that's going to give us a lot of material right there. So
and then that's the little part up there in the top, and there's the diameter over there.
That's right. See, so this is the thread insert that I'm going to machine, and see, kind of give you an idea,
sure.
three visuals how it's going to look, and see, it's going to be a light press fit. You know, because of the thin wall, we don't want a really heavy press fit, so it's going to be very light press fit, and then we're also going to use Loctite.
Oh, okay. I understand, because I know that we got to we've done a lot of Loctite research around here.
Yeah, especially for watchmaking and micro machining, we've done a lot of research on Loctite. So, and we'll get into that when we're at the stage where when we're ready to press in this thread insert. We're going to share with you the exact Loctite part number we're going to use, and why we selected it.
And all the steps we go through
exactly
to make it really work well. So that's going to be a nice lesson.
Yeah, I think
fantastic.
So.
Well, that's a nice looking blueprint. I feel good.
Okay, and then here's the drawing. This is, you know, these are the dimensions I figured out. So these are the dimensions of the thread insert.
Oh, that's right. You got to bore that thing out perfectly.
Yeah, it has to be perfect. See, it kind of shows you, you know, the outside diameters, you know what, 0.875. And if I'm correct, that's 7/8 of an inch.
It is.
Okay. So, and then this is showing you, you know, the major diameter of the threads is 3/4 of an inch. So, you know, not much to work with, but I think it's going to work out. It's still going to work out pretty good.
You just got to get your bore perfect.
Yeah, I just have to get it. Oh, that's right. I'm glad you mentioned that. Okay, so the thread insert, I'm pretty confident that that's going to go pretty smoothly. Okay, but when it comes to boring out the threads on the bracket, okay, how am I going to hold this? I'm going to actually have to change out the 3-jaw chuck to a 4-jaw chuck, and I think I can hold this pretty good. But the really critical point is I'm going to have to find the exact center
to those bottom holes.
Exactly, because see, this gets mounted, and if I'm off a little bit when I bore this, the lead screw is going to bind.
And it's going to wear right into that bronze.
Yeah, it's not going to be a good situation at all.
Talk about backlash buildup.
Yeah. So I've been thinking, I think I've got a good idea how I'm going to accomplish that. And obviously I'll share that. I'm actually going to share all the steps, the machining steps with you guys. So we're going to show everything, right, Lance?
Absolutely.
We're going to show the machining, when we press in the part.
And the results.
And the results, right.
Yeah, we're a see it all the way through with results kind of guys, yeah.
Yeah. And, you know, obviously we're hoping that this is a successful project. And I'm pretty confident, you know, now that I've modeled it into SolidWorks and seeing how it's going to look, I'm pretty confident it's going to be a successful project. But if not, you know, worst case, we're just going to have to purchase these brackets. But we really don't want to do that. We really want this to be a successul project because...
And it's kind of fun. I personally we just want to get back to machining parts. That's what we're really gung-ho about around here.
That's right. And it's going to be really fun, you know, to play around with these Acme threads, you know. So that's a new thing, and, you know, that's going to be a lot of fun, I think.
Great.
So, yeah, so as you can see, I think I'm ready to start machining unless you have any thoughts.
I do. I'm going to share the material that I've already purchased for you.
Oh, sure, that's right.
I didn't want to put any delays into this project. People like to see machining. We want to get right to it, don't we? Well, we had two choices. Well, first we decided between brass and bronze. Now, that was interesting education there. Brass is out of the question. It is needed in some applications, but durability over long-term rigidity and such have you, the bronze is the winning formula by
Sure.
by weight. It wins by weight.
Oh yeah, it is heavier.
It says a lot about it. There were 2 choices in that bronze category, huh? We did a little homework.
Yeah.
We did a 954 and a 932 was the research came down to those 2 models. Is that right?
That's right, because the 932 is your common bronze.
It is. And the 954 has got 10% aluminum in it. So it's got a lot more wear factor that could risk on the ball screw, I believe. Is that correct?
Yeah, I think that's what we were afraid of or you're telling me, you're the expert on the material, is that the 954, your concern using that was the wear factor it can have on the lead screw.
Yeah, I don't mind making a new nut and a new nut press. I don't mind buying that, but you don't want to mess with the ball screw, the lead screw there. I mean, the lead screw or ball screw. You never want to mess with any of that. You want to mess with these parts that wear.
Yeah, I agree with that because, let's think about this. Let's say that, we update these with the thread insert and it's successful and we use it years later. We'd rather have the thread insert wear out because we can easily press it back out.
Press in a new one.
Press in a new one, we're back in business.
I bought you enough material to get it right and to make extras.
Yeah, so no, that's definitely, so 932, yeah, that definitely seems like the right material.
So here's where we want to come in with you, okay? We're going to take you along with this exciting journey to machine these Acme threads in this bronze and see what kind of tolerance we can accomplish for the long haul, not for a one spinning table movement here. I want to know that backlash today and a year from today, and I want you to come along and join us. So let's go over to the lathe and let's get started making some neat machine parts together. We're going to have fun.
Great.
Okay, we are off of that lathe now with Patrick here, and you've seen we just made those pretty little
the thread inserts.
Yeah, the little blanks, and we took the two existing lead screw nuts and we bored them out. Look at how nice they look in there, don't they?
Yeah, look at the.
Wait a minute, let me get a show off the part picture there. All right, Patrick. Well, what are we going to do next here? Now you've got everything you need.
Okay, we're going to be using...
I noticed there's no threads yet.
Okay, yeah. What we decided to do was, okay, when we made the thread inserts, we were going to thread these, but we decided not to. What we're going to do is we're actually going to use Loctite. It's a Loctite retaining compound. And so we're going to Loctite these in place, and then we're going to let it dry overnight. So in the morning, after, it's all dried, then we're going to take these brackets, check them back up in the lathe, and then we're going to actually machine the threads with a thread insert in the bracket. Because we actually think that it'll be more accurate that way, for one.
Well, I guess we're going to test some Loctite, right? Because those aren't press fit.
That's true. Yeah, that's an interesting thing. Okay, when we're done with this project, we're going to get into more details on Loctite, to talk about like why we use 603 and so forth. But basically, Loctite recommends that you leave 1 to 3 thousandths of play. See, so what you don't want to do is you don't want to use this retaining compound on a press fit part, because if it's press fit, what's going to happen is it's going to squeeze out all the Loctite. So they want that play between the two parts, so that way it creates a layer of Loctite between the two parts. And we'll show you some diagrams showing that later. Okay, so really important when you use any type of Loctite product. In this case, it's
a funny bottle right there. Most people probably aren't familiar with, huh?
Yeah, it's actually a 3-step process.
Oh,
and the reason why it's a 3-step process is because the parts we're dealing with are non-ferrous parts, meaning there's no iron in these parts because it's bronze. Okay, and for that reason, it's critical that we use primer. Okay, so but before we use the Loctite products, we first, which I already did already, I cleaned all the parts with acetone because we don't want no oils, grime, or dirt on the parts. Definitely no oils.
Well, I noticed you didn't use your isopropyl.
True. As you can see, I am wearing gloves because I just don't want the oils from my hands to get on the parts. Okay, so they've already been cleaned with acetone. Okay, what I'm going to do next is now I'm going to prime the parts. Okay, so let me do that now.
How would you rate that finish in that bore, would you think, on those sleeves? A little bit of a... I mean, they're not a mirror finish, so they're...
But they're definitely smooth. Like, if you feel it with the touch... I chose an insert to give us a really smooth finish. Because I didn't want, because we want... They're really close-fitting parts. They aren't... Obviously, they aren't a press-fit part. But, we didn't want ridges and so forth.
Oh, okay. That's good information.
Yeah, if you notice in the video of the machining we were doing on the lathe, I actually used a high-speed steel lathe insert. I'm not sure if many of you may have noticed that, because with the tooling we're using, you typically use the carbide inserts. But those are... I forget, those are from Arthur. Do you remember the company A.W. Arthur? It's a company they're made here in the USA. And the company makes these inserts in high-speed steel. And they work great. I use them on brass. I just use it on brass and bronze, but it gives a beautiful finish.
Okay, you prime both parts, huh? Okay.
Yeah, I do both sides.
AD and OD, okay.
I'll tell you, give you a secret. We have a pretty big air line set up here. It goes all the way in the workshop and over to the machine shop, over to the workshop.
And one stops by the kitchen.
Yeah, by kitchen. So that's a lot of lines, and we have absolutely zero leaks.
Yeah.
And we went through a lot of experimenting.
I think we got about 20 some odd drops with it. Not one drop, not one leak.
Yeah, and I'll tell you, one of the secrets is using this primer on all the fittings. And we did a lot of testing, and this really works.
So that's why our air compressor's on 24 hours a day, 7 days a week, and it never runs.
Yeah. Yeah, because believe me, years ago, we were located at other places, we had the typical leaks like everybody else.
We just ran it when we were working, turned it off when we weren't working.
Exactly. And it just bothered us. I said, you know what, we got to figure this out. Okay. So that's all the parts are primed now. So let's go ahead and let this dry for a few minutes and we'll be back.
Okay, thank you.
Okay.
Well, now you've applied that primer, huh? You're all done in there, all dry, huh?
Okay, yeah, when it was drying for a few minutes, I went ahead and I was shaking this. It's really important. So this has been shaken very well already. And so what I'm going to do, let me tell you what I'm going to do. So I'm going to apply Loctite on both parts. I just like to do that. So I'll apply some on the bore. And then mostly I want to be sure I get it on this part very well. And then when I insert the part, you're going to see that you want to insert these in a twist turning motion. So as you're pushing it
almost like you're threading it in a way.
Exactly. Like there's
a fake threads.
Exactly.
You're creating threads, yeah.
Yeah. And that way, they want you to do that so that way you get a good layer of Loctite around the whole circumference.
And not just pushing it out the other side.
That's right.
And hoping it gets in some little nooks and crannies, yeah. Makes great sense.
Exactly. Okay, so first of all... Yeah, remember that because we're going to be doing the twisting motion, you don't have to... So I'm just putting drops.
Oh, where you're going to start.
Yeah, see, just like that. Not much. You really don't... Probably put up maybe more than I need. But like I always say, better more than not enough. Okay, that's it. I'm going to be pushing that side in, okay. Yeah, that's good enough. Okay, so like that. So I do that. Oops. Okay.
Watch the twist.
Oops. Okay.
That's actually a brilliant idea from that company.
Okay. Perfect. So I want it flush right on this side because I purposely left it a little long, the length longer on this side. Because tomorrow what I'm going to do is I'm going to face this so it looks perfect.
Oh, when you thread it?
Yeah, when I thread it. So tomorrow I'm actually going to face it. I'll chamfer it and then we'll thread it.
Are you? Oh, okay.
Okay, that's it. I don't think we have to show the other one on camera.
No.
So yeah, we'll just let this dry. We're gonna let this dry overnight, and then we'll see you back in the morning.
Some more fun lathe machining coming up.
Exactly.
Bye.
Bye.
Okay, we're back with Patrick now, and there he is, and he's smiling still. That's a good sign because that glue, I believe, it's cured about 18 hours now or so.
Yeah, about so.
About 75 plus degrees around here, nevertheless.
Yeah, everything looks good. They're really tight. But the real test is going to see, is the Loctite going to hold on when we machine the thread?
Yeah, it could spin right out of there. So you're going to get a whole lesson at the end of this anyway on Loctite, right? We're going to try to do a little sharing about what we know.
Yes, because we're actually, just kidding aside, we're actually really confident in Loctite's ability to really hold on to these parts. I mean,
boy, do you have to do it correctly, though.
You do. That's the key. That's why we really stress the 3 steps process on this. You know, cleaning process with the acetone, the primer, and then the application of the Loctite. So really important. If you do that, yeah, you'll be really amazed the strength of this adhesive. So yeah, so we're ready. We're ready to start machining this morning.
So we're going to go machine, and as we machine those 2 nuts, now you could have just made these, huh?
Yeah, you know, in case anybody has any questions, you know, why didn't we just make the brackets, you know, on our CNC mill? And the reason why we chose the thread insert method is because we want the ability in the future to easily machine new thread inserts if we need to.
So you just heat it up and like press them out, right? Or if you have to.
That's right. Because the Loctite is really strong. So what you do is you just heat it up. I forget the temperature they recommend, but you basically heat it up, and you can press it out, and then you can just press a brand new one back in. And see, you don't have to machine a whole new entire bracket again.
Or, yeah, and you don't have to bore it out anymore either.
That's right. It's all bored. It's all ready. So you just have to machine the thread inserts and press them in.
So we're going to go over and machine, right? And then these 2 lead screws right here. I guess we're going to do, how are you going to take an approach with the lathe there?
Okay, so what I'm going to do is, when I machine these thread inserts, I left about 30 thousandths material. And the reason why I did that is because once we press these in, you know, I'm going to put them back. I'm going to chuck this back in the forge-jaw chuck. I'm going to indicate the bore because, you know, it should be pretty accurate. So I'll get this chucked up, centered. And then I left a little bit of material, about 30 thousandths, because I wanted the ability to take a skim cut just to make sure we're exact centered. Okay. And then once I do the skim cut, then I'm going to machine the threads.
Oh, okay.
Okay. And then when we're close to the final dimension for the Acme threads, okay, we're gonna, as you see here, we've got the X-axis lead screw and the Y-axis, and we're gonna use these to test the fit. Okay, because aren't we looking for a certain fit length?
Yeah, I'm trying to be. Here's what it is, guys. It's got to be snug, but like a glove, but not quite a glove. It's got to be still loose enough to last for more than 2 weeks.
Right, exactly.
You can't get loosened up in 2 weeks. So we're looking for a happy medium between too tight and the way they were, too loose.
Yeah, you have to have a little bit of clearance. So.
Right, because the design here is the bronze wears and the lead screw survives. But
that's right.
We're going to do some full-length testing on these as we get them closer and closer. It's going to be fun to watch. You guys are going to enjoy it.
For the final test, we actually have to test the fit through this entire thread length. Because these aren't brand new lead screws. These are used lead screws. Although they're in very good condition.
They may have a high spot and a low spot.
Exactly. So we got to test the entire length to make sure it doesn't bind.
So a little tedious for you guys to come along with, but we're going to show you how we do this and get it. We're going to find the most happiest of happy mediums for both the X and the Y.
Yeah.
And that's going to be it. And we're going to have the best meal we can make.
We sure hope so.
Let's go do some spinning.
Okay, sounds good.
Bye.
Bye.
Well, you've come this far. I guess you're in for the ride with us. Yeah, we're smiling. We're happy. Look, we've never cut Acme threads. Let's start there.
That's true.
Okay.
Never have.
We've used Loctite for decades, but we've never used Loctite on this scale.
Yeah, not to this large scale. You know, we do use threading compound and the retaining compound in watchmaking, but not in the parts this size.
No, because we were going to do a press fit. We thought about doing a press, but we bounce everything off the walls before we start.
Yeah, you got to talk it out, you know, because, you know, we don't want to redo a project. You know, it takes a lot of time. So we like, you know, so Lance and I talk about it. And yeah, so we were going to do a press fit, but we thought, you know what? We use the Loctite retaining compound with great success in watchmaking and even for general tools and so forth. And we go, you know, why not use it on this threading insert? So that's what we decided to do, and we thought we'd share it with you. And we thought the ultimate test was to use the Loctite retaining compound on this thread insert, press the insert in, take it to the lathe, bore it to size, and machine the Acme threads. And if that Loctite holds up, I thought we both agreed that would be a good test case that, hey, if it holds up to that lathe machining, it's going to hold up, you know, and use when it's all assembled.
So long as you've pointed out, though, so long as when it's applied correctly and prepped correctly.
That's right.
That's why forget about it.
That's why we preach, you know, especially in our case, follow those 3 steps. Very critical.
And you'll have smiles on your face like us.
That's right.
This took forever to do. If you've been here with us, and we're being honest, this first one, we only have 2 of these nuts. That's all. 1 each.
That's it.
And actually, we don't have any spare parts.
No.
And we could have just heated this up, took it off, put another one in. We could have made another bushel. But
we could. Yeah.
But, you know, you never know. We're using a 4-jaw chuck or whatever. You saw all that, you know.
Yeah.
So the results are beautiful. It took us forever to do this first one. And like anything else, it took just a little short period of time. And the second one was all done, wasn't it?
Well, you know what? I'll admit, you know, the difficulties with the Acme in comparison to the V threads is the depth of the thread.
Yeah.
You know, the depth is so deep. You know, the depth here is 60 thousandths of an inch. You know, so it's quite deep. And that's the thing, you know, it's one of those things where we, you know, especially for the first part, we had to test it, you know, turn it a little deeper, test it, because once you go over, then there would be too much play.
So what we learned here was the correct bore and then the correct thread depth.
That's right. We got that fill we were looking for.
And I go, oh, it feels so nice. It is less sloppy than this Z-axis one that we purchased, you know. We purchased this one because the Z didn't have one.
That's right.
So we're fine with that. But on the X and the Y, we're trying to shoot for that higher tolerance here to fit our work environment.
But like you said, it's a shame that we didn't have like 20 parts to do.
Yeah, once we got this one done, I could have just
so fast.
Rolled them off the machine there.
Yeah.
I love production runs anyway.
Yeah, it's always the first part that you're doing for the first time that takes a long time. But yeah, we're really thrilled that everything went just as planned.
Hey, let's take a second and share some real fine details on the Loctite, huh?
Yeah, you know what?
Nice lesson there.
You know, there's a handbook that you can download from Loctite's website. And this is something that I really, if you're going to use the Loctite retaining compound, I definitely recommend that you download this. And we'll provide a link to this document in the description.
Yeah, take care of it.
Okay, so here's the document from Loctite. It's called the Retaining Compound Design Guide. And it's really, you know, it's about 30, oh no, actually it's shorter than that. It's about 20 pages. Okay, and I just want to show you a couple of pages. But really helpful information in here. You know, it talks about the different metal types.
He's on the page that convinced me, just so you know. You see the green down there in the bottom right? I got what it was trying to say.
Yeah, see here, what they're saying is, see with a typical interference press fit of 2 parts. See, they're saying because the surfaces of the parts are never perfect, they claim that on average you're going to get 30% metal-to-metal contact only. So you're going to have a lot of gaps. You know, we're talking at the micro level under a microscope. So you're going to get 100% surface-to-surface, contact. So you're going to have a weak. It's not going to, the strength's not going to be strong. So that's how they promote their retaining compound. Is they show it with this green. The green represents the Loctite product.
Yeah. And
see with that, they're saying, see, with their retaining compound, it fills in all the gaps to accomplish a 100%, contact, between the 2 parts.
And we don't want to get carried away here now. This only works for cylindrical items.
That's true.
This is not a flat product to flat product. You cannot mount the roll bar in your off-road truck with this stuff.
Exactly. Good point. Yeah, it can't be, 2 plates. It has to be a cylindrical part. Like our 2 parts was a good example, of using this product. Okay, the other important thing is when you use this product, you don't want a tight press fit. And they actually recommend, so if you look at this graph, this graph is showing you the strength. See, the higher see, number 1 showing you the maximum strength. And see, as a clearance of the 2 parts is I guess, if there's too much clearance, as a clearance increases or enlarges, the strength decreases. And what they recommend...
Oh, sure, there's a line.
Yeah, there's a line. And they're saying for optimal strength, they want to see a 1 to 3 thousandths of an inch clearance.
Anyone could have machined this press. We could have made this press fit. Problem is, we would have pressed out all the Loctite.
Yeah, if you notice, after I had machined the thread inserts, I showed you how we, the type of fit we were looking for, where I could push it easily through.
Yeah.
See, we did that purposely because, like Lance just mentioned, if it's too tight of a press fit, it's just going to press out all the Loctite, and you don't want that. You want some of the Loctite to retain within the 2 pieces of metal. So that's why that's really important. But even if it's a 0 clearance, you're still going to get good strength. You just don't want a tight press fit.
That's right.
So we thought that was important to share. But definitely,
just a word of caution though. It's a great read, but it is a little pro-ish, over-the-top Loctite.
Well, it's a little.
I gotta be honest. There's a lot of marketing there, but I did read it intensely and made highlight notes. We did discuss each part.
Yeah.
And overall, it's a great educational product.
Yeah, definitely.
And it opens you up to all kinds of. You wouldn't believe some of these tools that Loctite makes.
Oh, yeah.
There's applicator machines and stuff. Can you show them?
Oh, yeah.
Come on, guys. I love tools like all of you. Patrick's already making a list,
Yeah, got a lot of these tools.
Check these out. Look at that.
Different applicators.
Look at that thing. I've never seen that in the hardware department. And you want some tips? How about some tips? I got some tips for you there.
Yeah, look at all the tips.
I just wanted to share that.
Yeah, so they got a lot of goodies you can purchase.
Oh, boy, more tools.
Yeah. Okay, so that's what I wanted to share. So I think that wraps up everything for me, huh, Lance?
Oh, and you sure do wish so. Not so fast. I've got just a small little bit.
Okay.
I guess we could discuss the color, but everybody knows what a dial is.
Yeah.
A dial on your tables.
On the hand wheel.
Yeah,
dials.
your hand wheel dials. And this one is a new modern one. It has a bit different to it. I know you can't see that, but it's different. A little more up-to-dated. But anyway, all of these are cleaned up perfectly. And we got to discuss the color, and you're going to use a special process to color these, highlight all these digits.
Yeah, we're going to fill in all the engravings.
Yeah.
And I think we've demonstrated that in one of our past videos, but we're going to demonstrate it again because we didn't, the example we showed was on a flat piece of metal doing, engravings on a flat sheet. But we're going to show doing it on these dials.
Which is a daily use application.
Yeah, that's right.
So can it last?
Oh, and we decided we're going to do it in red, right?
That's the color you want? Okay. Well, it's your project. I'm turning these over to you. You like doing that coloring. Now, the other thing is, can I just go one more item here?
Sure.
He may not be off the hook just yet, and here's why. we shot for a tightest tolerance possible without the ridiculousness of we hope when we build it, no binding. we can work with that.
Yeah, we intentionally left a little bit of play or a little bit of clearance in there.
But far tighter than the factory.
Oh, a lot tighter, right.
In fact, we weren't wondering if we're doing something wrong, and then we realized, no, we were just being a little too cautious.
Yeah.
So they're perfect. To us, they're just so you know, they're both equally perfect. There's no difference between either one of them. But each one's built to their own lead screw, even though they're exactly the same. And we're going to see about 1 year from now, aren't we? We're going to go for as long as we can and start keeping an eye on that table and test the table from time to time and see if kind of backlash we start getting, if any.
No, that's good. Yeah, let's see what the longevity gives us.
Right. I mean, anybody can make something perfect and tight, but how long can that really last? Especially when it's a designed wear surface. So that's all I have here.
Great.
You can get some dials done. You might be able to brag about having something done around.
All right. Bye. Okay, we're out in the machine shop, and Lance has some lathe accessories he wants to share with us.
Well, this is on the lighter side of things around here in Tentsville. This segment right here is dedicated to our darling friend Emma at Emma's Spare Room Machine Shop.
Oh, sure.
Who has cast a steady rest as that is. And just so we get started correctly and properly as we do true to form around here, steady rest. Definition of steady rest. A rest in a lathe or grinding machine in which long, round pieces of work may rotate, but without eccentric movement. Called also a center rest. That's dedicated to Emma. Now, Emma is not why we did this segment. Somebody asked us, do you use a steady rest on micro machining? And I said, well, that's a good question to ask us. We haven't shown any of that yet because we're still building spindles, right?
Right. So
this one's from an 11 by 27, and these are opens, you notice, because they don't start getting that close over lock until they get bigger.
Right.
And we've seen steady rests, the kind that the machines may have up 2 or 3 of them along the bed of the lathe.
Sure.
And they're lifted up by hoist on a crane with an eye hook in them. They're so big. And many YouTubers make them, right, Patrick?
That's true.
I've seen guys weld these things, and I've seen people use those ball bearings, you see. You know, they use those bearings in here.
Yeah, that's right. They add the ball bearings where the surfaces would touch the workpiece, right?
Yeah, there's some not so good reasons you don't want those. But that's...
Well, personally, what I heard was why you don't want to use ball bearings is because metal chips could easily work its way in between, you know, the ball bearing surface and the workpiece surface, and that could be a really bad thing. And see, with the metal on metal contact, you're less likely to have that issue. Yeah,
and people really do the ball bearings because they're fearful of the marring of the metal and all that. But you've got some trade-offs there, and you got some trips and techniques with oil you can use, and some emery paper I've seen lately too. Kind of trick that you use oil and emery paper and it keeps smooth, but doesn't gather so much. But you have to test all this stuff out for yourself in your own work environment. But that's not why I'm here. I'm here for Emma. Emma made a cast one of these. She casted it a little wrong and it needs some rework. This is true. But she painted it was a beautiful white when she got done. So I've always picked on Emma and her little steady. I call it steady. Yeah. I asked her when she come to California from Australia where she's located. I said, did you bring along steady? I thought maybe she had a travel companion named Steady. So this is the biggest one we have here at Active Atom for the 11 by 27. And I found...
the lathe real quick, and that belongs to the lathe I used to machine those thread inserts.
Oh, the Acme threads we just did in the show.
Yeah.
Okay, and then I said, oh, look, we have a smaller one. Somebody asked me if we have and how small they are. So here's one for a mini lathe that a lot of guys might be familiar with.
Yeah, so you show it with the next... So you can see the size difference.
Yeah, see there? I said, well, you know, we're a micro machine shop. This is still pretty large work for us. So I asked Patrick, can you do something for my little skit and bring me something out that is kind of like neat, you know, that how small can a steady rest go?
Sure, of course. You know me with my 11 accessories.
Fully restored, by the way. Here she is. There's our little, I'll spin it around. It's a little 11 right there. Got a little 11 on it.
That's right, okay. Oh yeah, there we go. Sure.
And Levin's a little different than everybody else. You'll notice bronze or brass, whatever's going on here.
Yeah.
And then you're going to notice this little guy here. What's it hold at? A half-inch round diameter? That's kind of funny. It's a beautiful piece, though.
But you're right. Where the other manufacturers, they chose, I guess, bronze or brass.
Yeah, and these are hardened steel.
Yeah, hardened steel.
Yeah, I'm a little
really interesting.
It's just the way Levin and Son looked at it.
Yeah.
Interesting to share, but I'm glad somebody asked that question, and I'm glad we could do a little shout out to our dear friend Emma. So hi Emma, huh Patrick?
Yeah, hi Emma.
Yeah, this was for you, and bring Steady back. We miss her. Okay, thank you.
Right, thank you.
As watchmakers and micro machinists, Patrick and I thank you for following along with us while we take this journey. We look forward to bringing you another exciting show shortly.